Welcome to a journey through the intricate world of programming. Today we will delve into the importance of interfacing assembly and C++ in modern programming. Assembly language, though seemingly archaic, is still a powerful tool in the programmer's arsenal, offering unparalleled access to the inner workings of a computer system. It's like having a direct conversation with your machine, speaking its language and understanding its responses. In the realm of programming, interfacing assembly with C++ holds significant value. This combination allows programmers to execute low-level operations that are otherwise challenging to perform using high-level languages alone. By interfacing assembly with C++, you can write code that directly manipulates hardware, accesses specialized processor instructions, or addresses critical performance issues. One common way to interface assembly with C++ is through inline assembly. This method involves incorporating assembly code directly within your C++ source code. You can achieve this using the ASM or keyword, effectively embedding assembly instructions in your C++ program. Separate assembly files represent another method of interfacing. Here, you write your assembly code in a different file and link it with your C++ code during compilation. This approach makes your code more modular and easier to manage, especially with larger projects. You can also use assembly functions as C++ functions by declaring an assembly function with the extern CE linkage. This ensures that it adheres to the C function calling convention, making it compatible with your C++ code. Other methods include using inline assembly in GCC and Clang compilers, using an external assembler to compile your assembly code, or employing assembly libraries. However, when interfacing assembly and C++, it's vital to understand the calling conventions, register usage, and memory management of both languages. Moreover, platform-specific considerations may also apply. Therefore, always refer to the documentation of the specific compiler and assembler you're using. Understanding the interfacing of assembly and C++ opens a new dimension in programming, allowing for greater control and efficiency. Inline assembly is one of the most common ways to interface assembly with C++. Let's dive into how it works. Inline assembly is an intriguing concept that allows us to integrate assembly code directly into C++ programming. By using the ASM or keyword, we can embed assembly language into our source code, providing us with the power to perform low-level operations while still working within a high-level language environment. Imagine you're working on a C++ program and you need to perform a task that requires direct hardware access or specific processor instructions. Where does inline assembly come into play? Well, it's right here that inline assembly proves its worth. Let's consider an example. Say we have a C++ program where we want to move the value 42 into a variable named result. We can achieve this using inline assembly as follows. We start with our main function and declare our integer variable result. Next, we use the ASM keyword followed by parentheses. Inside these parentheses, we write our assembly instructions. In this case, we're using the mov instruction to move the value 42 into the result variable. The syntax would look something like this. We write ASM, then in parentheses and quotes we write mov %042, followed by a colon and $R in parentheses with the result variable. This code essentially tells the compiler to move the value 42 into the result variable using assembly language. The $R signifies that the result variable is an output operand, which means it will store the output of our assembly instruction. So in essence, inline assembly offers us a unique way to incorporate low-level assembly instructions directly into our high-level C++ code. It's a powerful tool that gives us the best of both worlds: the flexibility and ease of high-level programming with the precision and control of low-level operations. Remember, the use of inline assembly should be measured and deliberate, as overuse can lead to complex and hard-to-maintain code. But when used judiciously, it can unlock a new level of programming prowess. Inline assembly offers a seamless way to incorporate assembly language into C++ code, providing a unique blend of high-level and low-level programming. Sometimes keeping assembly code in separate files can be beneficial. Let's explore how to do this. One method of interfacing assembly language with C++ is through the use of separate assembly files. This approach allows you to write assembly code in a distinct file and then link it with the C++ code during the compilation process. Imagine you have an assembly file named myasm-dasm. This file contains a section for data and a section for text. The text section includes a global function named my_asm_function. This function moves a value stored in my_value to the EAX register and then returns. Now let's switch our hats to C++. In our main TTP file, we declare an external function, my_asm_function. Then within the main function, we call my_asm_function and store its return value in result. But what if we want to use assembly functions as C++ functions? Well, we can do this by declaring our assembly function with the extern C linkage. This linkage ensures that the assembly function follows the C function calling convention, making it compatible with C++. Let's consider an example. We have an assembly file myasm.asm. This file contains a text section with a global function named my_asm_function. In our main.tppa file, we declare an external C function, my_asm_function. And as before, within the main function, we call my_asm_function and store its return value in result. So why would we want to separate our assembly code or use assembly functions as C++ functions? One reason is that it helps keep our code clean and organized. We can group related assembly functions together in one file, separate from our C++ code, making it easier to manage and understand. Moreover, by using assembly functions as C++ functions, we can take advantage of the familiar C++ function calling convention. This approach can make it easier to interface between the two languages. By separating assembly code and utilizing assembly functions as C++ functions, we can maintain cleaner, more organized code. GCC and Clang compilers offer their own unique way of interfacing assembly and C++. Also, using an external assembler can be a powerful tool. Diving right in, GCC and Clang compilers support the use of inline assembly with the keyword. This keyword allows you to incorporate assembly code directly into your C++ source code. So instead of the asm keyword, you would use like so_int main. In this instance, the value 42 is moved into the variable result, all done in line within the C++ code. Now let's delve into the realm of external assemblers. An external assembler like NASM or GAS can compile your assembly code into an object file. This object file can then be linked with your C++ code. Here's an example of how you might do this. First, you'd write your assembly code in a separate file. Let's call this file myasm.asm. Your assembly function might look something like this: section.text global, my_asm_function, my_asm_function. Then you'd use an external assembler to compile this assembly code into an object file. The command might look something like this: nasm felf64, myasm, asm. Finally, you'd link this object file with your C++ code during the compilation process. The command for this might look something like this: g++, my_program main tpp myasm, and there you have it. You've just used an external assembler to compile assembly code into an object file and linked it with your C++ code. With the right tools and knowledge, interfacing assembly and C++ becomes a powerful asset in any programmer's toolbox. Assembly libraries provide another efficient way to interface assembly and C++. Let's see how they work. Assembly libraries are an often overlooked yet powerful tool in a programmer's arsenal. Think of them as repositories of pre-compiled assembly functions. These libraries offer a streamlined solution to integrate assembly code with your C++ projects. Here's how it works. You start by writing your assembly functions in a separate file. This file serves as your assembly library. For instance, we can create a file named mylib.asm. Inside this library, you define your assembly functions, each with a global directive. This directive makes the function accessible to the linker. Each function should be well structured, with a clear start and end, usually marked by the RET instruction. Once your library is ready, you can compile it into an object file. This process transforms your assembly code into machine code, which can be linked with your C++ code during the final compilation. Now, let's bring your C++ code into the picture. In your C++ code, you declare your assembly functions using the extern C linkage. This ensures that the C++ compiler uses the C function calling convention, making it compatible with your assembly functions. Then, you call your assembly functions just as you would any other C++ function. The result? A seamless blend of assembly and C++ in your project. But as with all things code-related, remember to be mindful of calling conventions, register usage, and memory management. While assembly offers unmatched control and optimization, it also demands precision and understanding. Also, keep in mind that different compilers and assemblers might have slightly different requirements. So always refer to the documentation of your specific tools. Now that we've explored the various ways to interface assembly and C++, it's clear that this technique is more than just a skill, it's an art form. Remember, practice makes perfect. So keep coding and let your creativity soar.